Okay, in computer science, there's two really important numbering systems. The first one we've already learned about is the binary system, and the other one is the hexadecimal system. These are just numbering systems like all other numbering systems, so you just need to know what the base is, and you should be able to use the same process to figure out how to write numbers in that particular system. This one is a little more complicated for people though, because if you look at this, hexadecimal, what do you think the base is? Well, hexa is 6, decimal we already know is 10. So the base in this system is actually 16. So we're going to have 16 to various powers. How many digits do we have in this system? Well, in a decimal there was 10 digits, 0 through 9. Binary, there was 2 digits, 0 through 1. Octal, there was 8 digits, 0 through 7. And now, hexadecimal, there has to be 16 digits. Well, what are they? Because that's going to be confusing, because we're talking digits. We can't, what happens when we get to 9? So we're going to start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we can't do an 11th digit because that would be 2 digits. So what we do is we use letters to represent digits. So what is a 10? A 10 is actually an A, B, C, D, E, F. What is an F? So 10, 11, 12, 13, 14, 15. But that's 16 digits, right? So we have 0. So we have 0 through F is actually 16 characters, 16 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. So what I'm going to do, just right above these letters, just so we remember, is that A is really a 10, a B is 11, a C is a 12, a D is a 13, an E is a 14, and F is a 15. So you can remember what the letters actually stand for. So this is a hexadecimal system base 16, and so we can write hexadecimal numbers and try to convert them into decimal and see what they would be. So let's start with a hexadecimal number of 1, 4. So this can be confusing, because when you see this, you think, well, that's a 14. But I've told you this is a hexadecimal number, not a decimal number. It's a hexadecimal number. So what would this be in decimal format? So what we do this time is, we have, as always in all kinds of systems, we have place values. And the first one is always the base to the 0 power, which of course is always 1. So the first place value is always a 1. The next one is the base to the first power. So that is actually whatever your base number is. So that's going to be 6. That's the 16's place. And this one is 16 to the second. So this gets a little confusing when you have bigger number systems, because these numbers kind of get hard to deal with. But 16 squared is 256. So this is the 1's place, the 16's place, the 256 place. So this is like groups. Whatever digit I have in here is the number of groups of 256 that I have. So those are pretty big groups. And then we could go 16 to the third, which is actually a group of 4096. So we can get pretty big numbers really fast. We don't need a whole lot of digits to get really big numbers here. Okay, so in this case, what is a 14? Well, that would have a 4 in that spot. I shouldn't say 14 because that's the decimal. So what is a 1, 4 in hexadecimal? That'd be a 1 in this spot and a 4 in that first spot. So how do you figure this out? Well, you take the digit times the place value and add them all up. That's what you do. So you have 4 in the 1's position, so that would be 4. You have a 1 in the 16 position, so that'd be 116. 1 times 16, for a total of 20. So this 14, or 1, 4 in hexadecimal, is a 20, is the number 20 in decimal system. Okay, Hopefully that makes sense. So I have 16 digits, and I can have letters now also in this to represent the 10 through the 15 spot. Okay, let's do another one. Let's see here. Let's erase this. And let me put in give you another hexadecimal. Let's do 3A. That's a hexadecimal number. What is that in decimal form? Well, an A is a 10, right? An A is a 10. I'm going to kind of secretly put that up there, a 10. 10 times 1 is 10. A 3 means we have a 3 in the 16 groups. So 3 times 16 is 48. Add them together and I get a 58. So a 3A hexadecimal number is 58 in decimal. Is that starting to make sense? I hope. Let's do another one. Let's take a hexadecimal number of FF. What is that decimal wise? Okay, F is a 15. So I'm going to have 15 ones. So obviously that's 15. And then I'm going to have 15 groups of 16. What's 15 times 16? Well, if you do that on the calculator, you get 240. I add those up and I get 255. 255. And you might recognize that number. That's an important number. Remember, that's the biggest decimal number you can get out of a byte of a binary digits. 8 bits. So 8 bits, the biggest number you can get is 255. So that's going to be important later. We're going to come back to that. So the biggest number I can get out of 2 digits in the hexadecimal system, FF, that'd be the biggest number I could get, would be a 255 also. Okay. Good. Let's do another one. Let's look at this. Let's look at this interesting question. If I have beef tacos for lunch, how many did I have? Interesting question. That is only for really smart computer science people. So what does that mean? It doesn't actually mean that you had beef tacos. It means that beef is a number. A beef is a hexadecimal number. So I have 4 positions, right? And this first position is the ones place. This is the 16's place, right? This is the 256 place. And this one is the 4096 place. So this is going to take some calculations. So I have B, E, E, F. This is a hexadecimal. Beef is a hexadecimal number. I want to convert it to decimal. So what do these letters represent in our 16 digits? Well, an F, if you remember, is a 15. An E is a 14. An E is a 14. And a B is an 11. Just always remember that, we start over the digits. We go 0 through 9, and then we have to do a 10, and we can't do that with with just one digit, so we had to make that an A. So an A is a 10, and you can always count on from there. Okay, so what do I have here? Well, I have 15 times 1 is 15. I would have 14 times 16. 14 times 16, and I've already done this on the calculator. That's 224. I have 14 groups of 256. 14 groups of 256. So 14 times 16 squared, right, or 256 is 3,584. And I have 11 groups of 4,096. Those are big groups, and I have 11 of those. 11 times 4,096, or 11 times 16. Remember, these are all base 16, right? 16 0, 16 to the first, 16 squared, 16 to the third, right? 16 to the 0 is 1. 16 to the first is 16. 16 squared is 256. 16 to the third is 4,096. 16 to the fourth would be some really big number. I don't know what it is. I don't know how far up we need to go. But so what I have right here is I have 11 groups of 16 to the third, or 4,096. So 11 times 4,096 is 45,056. I didn't line that up very good. Sorry. Okay, and so if I add all that up, I ate 48,879 tacos for lunch, because I had beef tacos. I had hexadecimal type tacos. Okay, let's just do one more. Let's kind of let's work this backwards. Let's say I have a decimal number of 27, and I want to know, how do I write that in hexadecimal form? Okay, so I have, I'm only going to need 2 spots here. This is the 16 to the 0 spot, and this is the 16 to the 1 spot, which means this is the 1's place and this is the 16's place. So all you do is and I could do, there's a 16 to the 2, which is 256, but 256 doesn't go into 27, right? So what I do is, like I always do in all these numbering systems, what's the first number that can go into 27? Well, 16 can go into 27. How many times? Just once. If you go into it twice, then I'd put a 2 in this spot right here, but it can't. Like, for instance, if this number here up here was 32, then my hexadecimal number, 16 goes into 32 twice, I'd put a 2 in this spot, and then I'd have nothing left over, so I'd have a 0 here. So 20, or 20, actually is a 32 in decimal form. But I'm converting 27 decimal form. So 16 goes into 27 just one time, so I'm going to put a 1 right there. I'll take 16 away from 27, and I get 11. And so I need to figure out, how many times does 1 go into 11? Well, it goes in 11 times, right? So what is the digit, the single digit that represents 11 that I can put in here? Well, it only went up from 0 up to 9, right? And then it started over. A was a 10 and B was an 11. So decimal 27 equals hexadecimal 1B. Decimal 27 would be a hexadecimal 1B. And I'm sure that's confusing, because all you're used to is decimal your whole life, and you have to think about numbering systems differently. But this is important. Hexadecimal is important too, when we're going to talk about colors in programming here pretty soon.